Really want to thank you for taking the time to join us today. Today's speaker has really been preparing hard for this presentation and has a fun and interesting demo system that he's come up with to illustrate some of the concepts. But before I hand it over to David, a couple of quick items to mention. A recording of today's session will be available after the webinar. I will quickly cover where you can access those recordings and share with your colleagues if they couldn't make it today. David invites audience questions. He really enjoys them. So please feel free to use the chat box to enter your questions. We'll try and answer those as quickly as we can during the course of the presentation. There's also some time scheduled in at the end for some live Q&A as well. Presenting today is Applications Engineer David McNichol. And so I will let David introduce today's topic. Welcome, David.
Yeah, thanks, AJ. Today's topic is going to be axis synchronization and gearing. Now, if you're familiar with Delta, you'll already know that we have a few gearing commands, but we're going to go a little bit more in depth today. We're going to talk about not only our gearing commands, but really just synchronization in general, how to get things set up quickly, and some best practices as you're trying to gear together or synchronize and cam different axes. So we're going to cover what is gearing. If you're unfamiliar with the term or how we use it here at Delta, we're going to give you kind of a definition to make sure that everybody's on the same page. We'll talk a little bit about different gearing applications, specific applications where gearing or synchronization has been very helpful. We're going to go over position gearing, just basic position gearing. How does it look? How do we set this up? We'll talk a little bit about virtual masters, and if that's an unknown word to you, no worries. We're going to cover that here in just a bit. Velocity gearing, you don't always just have to gear position to position. You can gear velocity, and we'll talk about some applications where that makes a lot of sense. Clutching. So how do you start the gearing process, basically, or how do you come in and clutch two axes together? And gearing to curves. So this is going to be another topic here. Again, it's not really a quote-unquote gearing command, but it is definitely a gearing application, or synchronization. So we'll talk about that as well. Here's a great example of an application where we're using gearing. This is a flying shear. Some of you may be familiar with this application here. If you're not, no worries. Basically, you've got material that's coming down the line, and you've got a flying cutoff or a flying shear here that's going to be moving out, and it's going to be synchronizing its speed with the material coming out, and you'll be cutting while this material is moving. So hence the flying shear. And we've got a nice example. I'll show you what this would look like in an RMC tools plot here as we continue on. Okay, so what is gearing? Well, gearing is going to have one master. So in this case, we've got our master gear here. And this is what we're going to be gearing to. So we're going to have at least one slave in a gearing relationship. In this instance, we've got two slaves. Both these gears here are going to be slaves. If you're familiar with the Delta terminology, these are each going to be different axes. So now, once we gear these together, these slaves are going to be following the master. So whenever this master moves, these slaves are going to be following, right? Just like what you'd expect from this physical setup here. So the axes or gears, they always stay synchronized. They're going to have targets that's going to make sure that these are always synchronized with each other. You can set up certain parameters and halts to make sure that say one of the axes goes a little bit too far off its target, you can make sure that each of these axes stop and that one doesn't continue to move while the one is stopped. So you can see they're all going to move just nice and synchronously. One thing to note here is that gearing commands are only sent to the slave axes. This can be something that's a little bit confusing at first. If you're trying to set something up, you may think, well, I need to send a separate command to the slaves and another one to the master. But actually, you'll only need to send these gearing commands to the slaves. The master will just continue to move as if nothing happened, really. And unless you set up a halt to make sure that everything stops when one of them stops, this master will just keep moving. It really doesn't know that other axes are geared to it. Okay, so what are some gearing requirements? Well, just like we said before, you're going to have one master. Another requirement that we will talk about here, and we can kind of see some of the results from, is we want a smooth target. So a lot of times with physical axes, say you've got two cylinders and you want these cylinders to be synchronized together. If it's just a one-to-one relationship, a lot of times not a gearing command, but just a simple move absolute is even the best way to go. If you've got two axes, they start from the same position and you want them to end at the same position, you can issue them the same move absolute command at the same time, and that'll give them both the same target. So they are synchronized together, but you don't really need to go through the gearing process for something like that. Where gearing really shines is where you've got a relationship that isn't just one-to-one. Maybe it's something slightly different. And we'll see how that looks here in just a second. Okay, so let's say you want to do gearing or synchronization, or maybe you want to be following a master, but perhaps you just don't have a smooth target. Well, one great option that we have is our track or track I-PD commands. Now, this is a plot from an actual system here, and what we've got is a stepped signal that's coming from a PLC. The yellow is this target step signal that we're trying to follow, and I'm using the track I-PD command here. And you can see that it's following this target very well, right? It's generating just a really nice, smooth actual position, and it's just following along with this target that is not very smooth at all. So we're able to, get past issues where you don't have a smooth target with a few different commands. Okay, and just like we were talking about earlier, move absolute from the same starting target is a great way to do, I would call it simple gearing, or gearing that has the same start point and the same end point. Okay, so here's a list of a few applications. The flying shear, we talked about that one here in the beginning. Animation can be a great one. This is more camming, I would say. You can cam an entire animation sequence to a curve and run everything. You can change the phase that different axes are in. If anyone has seen our 12-axis display demo, it's a great example of what something like that would look like. You've got one axis following the other, and they're all a little bit out of phase from each other, so it ends up looking like a sine wave. Curve sawing, great example. If you're not familiar with the application, a log will come in, it'll be scanned by an optimizer, and then a curve will be generated that will then be sent to the Delta RMC, and we'll be following that curve with the saw to make sure that we get the best cuts out of the wood coming in. Leveling presses, these are a great example. If you're interested in the leveling press, the leveling press application rather, we've got a few other webinars that really go in depth. I'll be covering it a little bit here, but I would really encourage you, if you're very curious about this application, if it's something you do often, go ahead, check out some of our other webinars on our website that really dive in depth into the leveling press application. Joystick, velocity gearing. This is a perfect example of where velocity gearing would be used, right? Maybe you have a joystick and you don't really want to be following this joystick one-to-one. really what you want to be doing is gearing the velocity, right? So when the joystick goes a little bit positive, well, your velocity is, slightly positive. When it goes heavily positive, maybe you have a faster velocity, and the same with on the negative side. So this is a perfect example of where velocity gearing is helpful. Pultrusion is another great example. This application is kind of similar to the flying shear, but it's a little bit different. Here's a really nice example of what's happening here. You can think of the material as this line here that's coming out. And we've got a few things that are going to be synchronized here. So in this example, there's basically two arms, one here and one there. These are both hydraulic cylinders, and what's happening is a clamp is coming down. We're retracting that cylinder here. Then this clamp releases, and this one comes down at the same time and starts to pull, so that these are pulling synchronously with each other, and they're making sure that you've always got this constant speed. And then to add even more to it, you've also got a saw here that's going to be also moving and making sure that it's synchronized with that moving material. So this is a great example of a little bit more of a complex gearing application. Okay, so electronically gearing cylinders. What does this actually look like on a physical cylinder? Well, the first step that you're going to have is going to be issuing the gearing command to the slave. So this slave is going to be getting a command, and it's going to be geared to the master. Next, what you're going to do is move the master, and after this master moves, the slave sees the master's movement and follows synchronously. So how I have this one geared up right now is not just a one-to-one, right? For a one-to-one, you probably just want to use the move absolute command. This is slightly different. So I can see as my cylinders move out, right, they hit their endpoints at the same time, but it's not quite a one-to-one ratio. Maybe it's more like 2/3 of the full extension here. So this is a perfect example of where gearing can be very helpful. So what does this look like in RMC tools? Say you've got, you know what you're going to be doing, and you're going to be setting this up. Well, the first thing you need to do is select a gear absolute command or one of the other gearing commands. We're going to use gear absolute. It's a really nice, easy command to work with. And then we're going to be choosing what is our master. So in this instance, our master is going to be axis 0. We're gearing to target position rather than actual position. This is another nice trick to do. Again, remember in the beginning we said we want a smooth target, right? So actual position, no matter how great your feedback is, it's going to have a little bit of noise, whereas target position is a completely smooth, nice target to follow. We're also going to be choosing the slave axis here. So our slave axis in this instance is going to be axis 1. Next, we set the master range. So this master, point A is 0 and point B is 10. And to see how that's going to work, we're going to set the slave range. So this is a one-to-one setup. Again, you probably don't need to use gearing with this kind of a setup, but it's fine if you like to, you can. But again, a move absolute would work here. But for this example, just showing you how a simple setup would be, this would be a one-to-one setup. You've got master. When master is at point A, slave will be at point A. So they're both going to be 0, 0 at the same time. When master is at point B, 10, slave is going to be at point B, 10. Okay. And the last thing we need to do is choose our endpoint behavior. So for this, we can choose a few different things, right? Endpoint behavior, it could be a fault, it could be a truncate or an extrapolate, a lot of different options, and it's just very application specific. Okay. See, it looks like there might be a few questions coming through. if you guys have any questions, feel free to send them through. I know AJ is monitoring those questions. AJ, if you want to jump in and ask one of those questions while we're presenting, no worries. Or if not, we'll answer them all at the end. Okay, so let's go to a live example. I'm going to show you two setups here. We're going to see a one-to-one with the gearing, and we're also going to see an endpoint to endpoint. So let me show you my physical system here. We've got a pretty neat little physical system. You can see on my screen here, I've got one axis that's traveling along the end here, my x-axis, and then I have another axis that's going to be my y-axis here. I also have a little marker that's attached here. It's connected to the whiteboard. The whiteboard's a little finicky, so we'll see how well it works, but let me go ahead, and what I want to show you is just a simple one-to-one gear ratio. One other quick thing I want to note is I'm connected to an RMC 200 right now, but the programming that we're using here and the examples that we're going through, each of these examples could easily be used for an RMC 150 or an RMC 75. So this program that we're going to be using here, RMC Tools, is going to be used with all three controllers, and the user programs that I've got set up here are going to work in the same way. So let me walk you through what's going to be going on with this simple gear absolute. Okay, first what I'm going to be doing is I'm going to be moving my x-axis to a position of 0.1. That's just bringing it to the start. I start out at 0, so I'm just going to be bringing it there. I'm going to wait until I'm in position to move on to my next step. Now, if you're familiar with RMC tools, this is going to be just information that you've seen before. The next thing I'm going to be doing is setting up my transition rate. Now you can kind of think of this as maybe an auto clutch would be the best term for it. But what this does is it says that my maximum speed I can use to clutch or synchronize together for my y-axis is going to be 10, and my maximum acceleration is going to be 50. So if this axis is out of position, which it is right here, it's going to be able to go into position by using these parameters here. Okay, so as soon as that's set, I'm going to issue my gear absolute command. And this is the exact same command that we saw in the slideshow presentation. This is a one-to-one gear. And after that, I'm going to be moving my x-axis all the way to the end of my stroke. And my x-axis is a lot longer than my y-axis. So you'll see what this one-to-one looks like. One other thing to note, I set my endpoint behavior to truncate. So it's just going to, it won't give an error, but it's just going to stop where we end. So let me go ahead and run this program, and we'll see what it looks like on the physical system. Okay, so we can see what this looks like, right? It traced this line here. Now, if I were to plot this on RMC Tools, you would see the same thing. So what I'm going to do is I'll run this again, and I want you to note what happens here. This axis is still geared together. So if I run this program again, the first command that I'm going to be doing is moving to 0.1. I just want you guys to note what happens with this top axis here, and note that it's still geared together. So you can see it traces back over that same exact line, right? What I want to show you now is how this looks on a plot. So here's red line is my y-axis, the blue line is my x-axis. I'm going to run this one more time just so we can see it on the plot. So it's very easy to see from this plot what's going on here, right? I can see that once I came back to the 0, 0 position with both, I'm synchronized up until a position of 10. Right? I can see my position right here. Up until a position of 10, I'm synchronized together. After that, the y-axis position is just truncated. It's just a flat line here. and my x-axis continues on. So that's what a one-to-one gearing relationship is going to look like. Okay, let's look at something that is maybe more of a more real-life example, something that you'd probably want to be using gearing for. So again, in this example, I'm going to be moving to 0.5, somewhere close to the beginning of my stroke. I've got the transition rate set up again. I don't need to do this again because I've already set it up, but it's good to have it in your program just to make sure that nothing goes wrong. After that, I'm going to be gearing absolute, master point 0.5, master point B 21.5, slave point A 0.5, and slave point B 10.4. So this is close to the end of the stroke for each axis, but you can see that this is going to be a different relationship. This is going to be a lot more of a end of stroke to end of stroke. You don't really have a portion where you're synchronized together in a one-to-one relationship, but you're going to get to the endpoints at the exact same time. And then again, we've got to move absolute. So let me run this program. We'll see how it looks. You can see we're still geared this relationship here, but look how our gearing has changed. So now this is a lot different than the one-to-one, right? We're at the end of the stroke with our x-axis and the end of our stroke with our y-axis. So let me show you what this looks like here in the plot. You can see we never have that one-to-one relationship, right? But you can also see that we hit the endpoints at the exact same time. So that's what we're looking for from gearing, right? So we want to make sure that things are synchronized, that they're hitting their endpoints right when we want them to. Okay, so that's a nice simple rundown of how you could use a gearing command. Let me jump back to my slideshow here. Okay, let's say you want to do something a little bit more complicated. Maybe you'd like to, rather than just gearing one axis to another, maybe you'd like to instead gear to a curve. Well, the first thing that you're going to want to do is create a curve. A curve, or I guess it could be called a camming profile, is basically a series of points where we've got this internal in RMC tools. I'll show you the one that I've got set up here. It looks very similar to this. But what I want to do is I want to have one axis be the x-axis, and I want to have another axis follow this curve here. So I can see I'm about at a position of 4 when my x-axis is at 1.5. So I want to follow this curve as I'm as one axis is moving out. This is a very useful tool. Can be used for things like curve sawing. Maybe you just don't have a nice, simple, linear one-to-one relationship. Perhaps you have something very custom like a curve. That's fine, right? We can take care of it. We can handle it. And as you've probably seen, if you're not familiar with RMC tools, things are generally pretty easy in RMC tools to get set up and running. It's very quick, and it really doesn't take much of your time to get something that would be very complicated otherwise to get running. Okay. So after we get this set up, we're going to gear the slave to the master, again, just like we've done before. And the gear ratio will change based on the curve, right? So this is our actual position that we want to be in as the one axis extends. Master is going to be the x-axis and slave is going to be the y-axis. That's how we'll set this one up. Okay, so let's jump to our live example. And let's see what our program looks like here. Okay, so just like we've seen before, right? This example is going to start out by moving our master axis or our x-axis to the beginning of the stroke. We're going to set up a transition rate in case we didn't already have one. The difference here is we're going to be using the curve start command. So we're going to be starting the curve with an ID of 1. Again, we have our same master. It's going to be that axis 0 target there. We're going to be running 1 cycle here, and then we're going to be moving to the end of our stroke. So let me show you what our curve looks like. This is our curve here. This is the shape that we would expect to follow as we're going through. And let's see what this looks like when I run this here. Okay, so again, we're still geared with the old ratio. Now we're going through, and you can see that this curve is exactly what's been traced here, right? Now, one thing to note that I haven't shown just yet, you don't just have to go back and forth. Let's say I want to move this x-axis manually. I'm going to say I'd like to move it to a position of 10, right, somewhere in the middle. I can send my command here, and you're going to follow right back over that curve. So I can go backwards and forwards, maybe, okay, it's time to go forward just a little bit, go up to 15. You can see I can track backwards and forwards. So if you stop mid-curve, you can start again. And you can also see that this is tracking very well with the plot. So I'm going to move to 1 here. You can see that this plot shows exactly what we're looking at here. And I can move just back and forth on this curve, and you can see it just traces right over it every single time. So it's very consistent. It's doing exactly what we'd want it to do. And you can really clearly see here, let me move this to the close to the end of the stroke. You can really clearly see from this example exactly what's going on, right? So you can do a one-to-one relationship, or it just flattens out at the end. You can do an endpoint to endpoint, or you can follow something much more complicated like a curve. These options are all valid. They're all fairly quick to do, and really it's, it doesn't take much time. You can see that all of these examples here, they were only 4 steps, and a lot of that was just setup, right? The actual meat of what's going on is just this 1 step here. Okay, so let me jump back to my slideshow. And let's talk a little bit about clutching. There's a few different options that we have for clutching. And by clutching, if you're familiar with, gears, transmissions, clutching, it's just how does one gear get into the other gear? How do they get set up for that ratio? What does the transition look like between them? Okay, so for us, we've got a few different options. We can do a clutch by time, right, where my time is going to be basically the what we use to clutch. I can set up my final ratio. This is a 1-to-1 here. Something like this would also make sense with gearing, even though you've got a 1-to-1 relationship. You're clutching from different positions to the same position. So this can be a really nice way to do it. So within 2 seconds of this being entered, you're going to have a 1-to-1 relationship between 2 axes, this axis 0 target position and this axis 1 actual position, again, that X and Y axis. We can also clutch by distance. This command is a little bit more complicated. This is what we'll be using with our curve sawing. Makes it very nice when you've got actual positions where you want to be synchronized. This command is a little bit more complicated. You still have a ratio. You've got a master as well. But the difference here is that you've got a master sync position and a slave sync position, and then a master start distance. So what happens here is the master sync position is where the master will be when the slave is at the slave sync position. So when the master is at 5, the slave will be at 3. And the master start distance is how much before the master sync position should the slave start to gear. So in this case, when the master is at 5 minus 2, right, when it's at a position of 3, oops, sorry there. jumped out of my slideshow. Just jump back here. Okay, so when the master is at a position of 3 or 5 minus 2, then the slave is going to start to ramp up and start to synchronize with it. And then we also have gear position clutch by rate. Again, you can set up your ratio, your numerator and denominator. You set up a master, but in this case, you instead are setting up a basically an acceleration and a jerk for how your slave axis is supposed to synchronize with your master axis. So all of these have their place, all very useful, but many different options. It's very much so whatever you need it to be. Okay, here's a great example of where clutching is being used rather, the flying shear. So we saw what a physical system looked like a little bit earlier. In this diagram, you can see my master axis is a rotary wheel, and then I also have a cutting axis. So this rotary wheel is spinning material forward. This cutting axis is going to synchronize with the speed of the material, and as it's synchronized, it's not really shown here, but you have a saw axis as well that's going to go across and cut the material. So the master axis is always running. Cutter axis is geared slightly before the cut, while the cut, and slightly after, right? So we don't care about this axis being geared when the saw isn't touching, but we want to be geared a little bit before and a little bit after when that saw is cutting, just to make sure that everything is nice and synchronized together. It's a challenging application, and it really is made simple through gearing. The program I'm going to show here is a little bit more involved, but we'll get to see how it's all done. And I've got a nice simulated setup here for this. Okay. So this is my flying cutoff example here. First, I'm going to make sure that everything is zeroed out. I also have another program here that just kind of zeroes everything out. I'm going to run this here, make sure we're all zeroed, and I'm going to send my saw back to a position of 1. Okay, so everything's set up to go. I'm just zeroing out all the positions, making sure they're where they need to be for the start of this. But the meat of this, where basically everything is done, is this gear position clutch by distance. So I've got a 1-to-1 ratio once I am geared. My master is going to be axis 6. This is my spinning wheel, right? My feed axis. My master position is going to be my cut length. So I've got this set up as a variable, so I can actually change this cut length as I'm going. It makes it a really nice program because you're not locked into using one setup or another. You can very easily change this as you please. Slave sync position for us, we just called it 4. This is kind of just a number pulling out. Nothing too crazy there. And then master start distance, 3.5. So 3.5 units, we're going to say these are inches. Before our cut length, we're going to start to synchronize. Now, once we're synchronized here, this is what this bit target generator done means. It means that we're all synchronized and ready to go. We're going to change our master feed back to 0. At first, that seems kind of odd. Why are we doing this? The reason we're doing this here is because we want to make sure that our cut length is always achieved. So as soon as I'm synchronized, I know that I'm going to make my cut at that point. So I'm going to make that my next 0 point for my master. So the master is zeroed, and then my saw begins to cut. My saw is going to move to a position of 10. And then it's going to move back to a position of 0 once it's moved there. So it moves back and forth, and it's ready for the next cut. And then I move my carriage back to a position of 0, back to get ready to be synchronized with my master axis again. And then we'll jump up to the top and perform another cut. Okay. So let's see what this looks like in a system here. So I'm going to run this program. We'll see how it looks. Okay, so a little bit of let me plot this again just so that you can see it a little bit better. You'll see the next cycle a little bit easier. Okay, there we go. Now there's a lot going on in this plot. I know if you're interested in diving deeper into this application, just let us know. Go ahead and shoot us off a question or contact us. Feel free. We'd be more than happy to go over this with you. I see there's a couple questions about the curve tool. Let me just finish this section here, and then we can answer those questions. So I want to see what's going on right here. It may be a little bit difficult to know it, to see exactly, but I'll try to do a good job of explaining everything that's going on. Let me get rid of a few of these things here so we can see a little bit better. Okay, this red line is my my carriage actual position, right? The carriage that's holding the saw. And this kind of dark purple line, maroon line, is my master feed. So I'm coming along here, and right when this master feed drops, this is where my cut is happening. So I can see right before I dropped here, I'm at a position of 10, all right? So that's what I had set up as my cut length, was a position of 10. So once I get to that cut length, my velocities, they should be synchronized together. You can see that these lines are both flat, but it's easier to see my target velocities here. You can see at this point, a little bit before, right when I get the cut, and a little bit after, I'm going to be synchronized together. And while I'm synchronized together, my saw is going to be doing my cut, right? It's going to go up to 10, back to 0. This black line is my saw. So my cut takes place, and you can see because these two velocity lines are just dead on each other, everything is synchronized together. Once my cut is done, the synchronization stops, and we get ready for the next cycle, the next cut. So everything is totally synchronized together. Okay, so again, I know that this is a kind of more of a complex setup here. If you have any questions, feel free to reach out. We'd be more than happy to give you a more in-depth example and walk through. Okay, ready for some questions, AJ?
Yeah, the first question is from Trey. This is about the curve tool, and it says, what do the dots on the curve represent? Could you talk about that for a second?
Yeah, that's an awesome question. So these dots are the points that I've put in here. So each of these dots here, they're inputted by a user. I could input another one, right? I could say 30 and 4, and it generates another point here, right? I could throw in another point by double clicking as well, and I can drag points around. So there's many ways that we can adjust these, and really, I mean, they could represent whatever you like. So it could be, you know, maybe it's a position target, maybe it's a velocity target. It's really a very open-ended tool. Its purpose is generating some kind of a target, but you're going to choose what that target needs to be, or what that target is rather. But these points are set by a user. It's pretty easy to import points rather from something like an Excel file, but very, very open-ended. Yeah.
Thank you. The next question comes from Ron, and he asks, could you demonstrate loading a curve and then linking the program to the curve?
Sure. So bringing a curve in to the controller and then linking a program to that curve that's incoming?
Correct.
Okay. Probably the easiest way, let's say I had a new curve here, say 0, maybe 0. We'll just do a quick curve here, 3, 4, and 7, 2. Okay, so here's my curve, right? Maybe I want to follow this curve. Well, what I could do, new program, I'm going to go through this pretty quick. just for the purposes of this webinar, guys. But if you have further questions, I'd be happy to spend some time with you after the webinar as well. Okay, so then I'm going to say curve start, pick my curve ID. So for this case, I've got a curve ID of 3. And my program here, 3. This would be how I'd run my curve. Your question may be though, how do I import this, or say, from a PLC or an outside source? We've got a great command called the curve add command. It's a little bit more in depth, so I'm not going to go over exactly how all of this is going to fit together. But we've got a really nice help topic on it. So if you choose the curve add command, you press F1, you're going to see exactly how this works. There's lots of different options for throwing these into the RMC controller. But basically, what you're going to be doing is either putting your points into a variable table, or if it's a much larger curve, there's a few other kind of go around ways that we can do this and add multiple segments to a curve. But this topic is really going to go over kind of the nitty gritty of how you get it done. But the curve add command may be what you're looking for as well. You choose where your data comes from, choose your interpolation method, life cycle, and what new idea you want to create.
Thank you, great answer. The last question here that we have comes from Perry, and he says, is there a way to know the velocity and acceleration of a slave following a curve without plotting it?
Yes, there is, and that's another great question. So let's say I have these points here, and I'm assuming you want to know the velocity and acceleration, or the target velocity and acceleration, before you actually issue it. We've got these 2 icons here, show hide velocity, and so you can actually see what velocity is going to be generated from these points. And then also you can see the acceleration profile that's going to be generated from these points. So you can already see, you can tell what's going on and know if if these velocities and accelerations are going to be okay, or if you need to tweak your points. And you can see, maybe I don't like the the acceleration here. It's too far. I want to reduce it down. You can slowly kind of tweak your points here. If you have that option, you can move these around and you can just change how the whole profile looks. So another great question, yeah.
Great, that's all we have for right now.
Okay, perfect. Well, I'm gonna go ahead and jump back into our slideshow here. Okay, now I wanna talk a little bit about gearing with presses. This is another topic that is very common with gearing. It's another topic that really lends itself to gearing and benefits from it greatly. I'm going to go over it quickly. There's a lot to this. There's a lot of meat to what's happening here. Again, we've got another couple webinars that we have already published on the website. We're going to have a link to those in the end. But if you're really interested in diving deeper into the gearing applications, I'd encourage going through those. It's about 3 hours of just talking about presses and really going in depth into how we achieve what we're doing here. Okay, so what's our challenge, right? What are we trying to achieve in this example in specific? We want to press with multiple axes to a total force while remaining level. So this is something that might sound easy at first, but when you get into thinking about how is this actually achieved, it gets fairly complicated fairly quickly. So we want to maintain our platen level, right? We want to make sure that this top part here is level as we're coming down, and we want to go into a total force. So our solution is using Delta's gearing and custom feedback. Let me show you what this looks like. Okay, again, this is a complex diagram. I'm going to go over it kind of quickly. If you have more questions at the end, feel free to ask. But what we've got here is a 4-cylinder press. Each of these 4 gearing icons, each of these are going to be my physical axes. Okay, these are set up with both position and force feedback. To get these set up, I gear them all to a virtual axis. Okay, at first this sounds kind of funny. What is this virtual axis used for? This is basically just a target. This keeps these all synchronized together. So all of these gears, once they're set up with this virtual target, they're all synchronized together. Instead of sending individual commands to each of these gears, I can send one command to this virtual axis. They'll all move. These are geared together with position. So their position is all geared together. Okay, next, what we're going to be doing, and this is the part that can be a little bit confusing here, but we're going to be gearing to a master outer loop. And think of this as one big hydraulic cylinder. This is what we're trying to achieve here. We want just one big hydraulic cylinder. So normally with a force hydraulic cylinder, you're going to have a position feedback, a force feedback, and then one output. And what your output does is it's a voltage that goes to a valve. And that valve is not really controlling the position, it's actually controlling the velocity, right? So as that valve opens up more, you get a higher velocity in that cylinder. As it closes more, that velocity reduces, right? So really you're controlling a velocity. And so that's what we're trying to set up here. So we gear the virtual axis velocity to the master's output, right? So now this entire setup here, it looks like one big cylinder to this master. He puts out a voltage and he sees a change in velocity. But we still need one part of the puzzle. We need our feedback. So how does that look? Well, for position, we take the average of these 4 actual positions. So we average it out, right? Axis 0 through 3, all added together and divided by 4. And for our force, we take the sum of the forces, right? Because we don't want, if you say go to 20 tons, you don't want 20 tons on each of these axes. You want 20 tons total, but you always want to be level. So doing the feedback like this and the output like this, again, it can be kind of hard to wrap your head around, but it's basically setting it up so the system just looks like one big axis. It makes it very nice to control, make sure that everything maintains level, and also that we can go to any force that we want to, that's physically achievable. Okay, so what does this look like in user programs? Well, here is our custom feedback. This is where that feedback is actually happening, right? From the previous slide, we had the average of our positions and the sum of our forces. You can see that's what's happening here. This example is just with 2 cylinders, just to make it a little bit more simple. Works the same way as 4, but there's only 2 here. So we've got axis 0 plus axis 1 divided by 2, right? That's the average going into our outer loop. And then our sum of forces is also going in to our outer loop. In addition to that, we actually are calculating the skew here. Now this program is just always running. It's constantly calculating what the feedback is for that outer loop, that master control axis. Okay. Next, what we do, say we're starting this up, maybe our 2 axes are skewed. We calculate the average position of the 2 inner loops. Those are our 2 physical axes. And then we move them to the average. So all this is doing here, this is just a fancy way of leveling things. If you have a leveling point, you can send both of them to the leveling point. And then we're going to set our virtual to the target here. And again, I know I'm going through a lot of this quickly. If you want to go more in depth, reach out to us or check out some of those other webinars, and we spend a lot more time going through how to actually set this up, and we show you guys on a physical system what it looks like as well. Okay. Next, we set the transition rate, right? We're familiar with this command. This is how our axes are going to be clutched. And we gear the inner axis position to the virtual axis position, right? That's our first gear. That's the 4 little gears being geared up to that one blue gear. So transition rate is set and we're all geared together, good to go. You can see that this is set up for a 1-to-1 relationship here, right? So this is an example where a 1-to-1 gearing ratio makes a lot of sense. Okay, and this last step here is where things can get a little bit more confusing. But what happens here is we gear the velocity of our virtual axis to the output, the control output. Hard to see it here, but this says control output. But we're gearing gear velocity, clutch by time. We're gearing this to our reference number 3. That's our virtual axis. And we're gearing it to the control output. So now the virtual axis velocity is going to be geared to the control output. We can set up a ratio here as well, right? Maybe you don't want 10 volts to equal 10 inches per second. So yeah, we can set it up however you like there. All right. And for this, clutch time is set to 0.1 seconds. You could set this longer if you like. Really up to you. All right. And this is the overall program. So it does, I mean, there's a lot going on here. There's a lot of meat to what's happening. But all of this leveling application is really just condensed down to 4 steps. So although it might be a little bit difficult to understand what's going on, it really doesn't take too much time to get this going once you're familiar with it. All right. So what's next, right? If you're interested in using an RMC controller, maybe you're familiar with them, and this is just repeat information. But if you're not familiar with the RMC controllers, we've got a few different options. RMC 75, 1 to 2 axes, 150, 2 to 8, and RMC 200 up to 32 axes. Again, each of these controllers are going to be using the exact same software that we were seeing today. Each of these controllers have access to all of the commands and the programming that we used. So any of these examples you wanted to set up with these controllers, you'd be able to do it just fine, barring maybe the flying shear that used 3 axes, and we've only got 2 with this RMC 75. You could probably fit one in there, but you couldn't do it the exact same way. As far as Delta resources, we've got a very knowledgeable Delta sales team, technical support team, and distributors. Everyone at Delta and all of our distributors are very happy to, very knowledgeable and very happy to talk to any of you guys that are interested in learning more. We're always willing to help out, give an example, explain what's going on. Application docs, if you've got a specific application you're interested in, we've got a lot of documentation on how to do things, how to get things set up from beginning to end. For instance, the flying shear, the press applications, curve sawing, a lot of great application docs, and in addition to that, application specific examples. So for instance, that flying shear example is available on our website. And then we also have a hydraulic design guide. AJ will talk about that here in just a little bit more. Advanced training. So if you're interested in going more in depth with this, we'd encourage you to reach out, try to do our advanced training. It's a 3-day course here at Delta. You get to come and check out the physical systems. For instance, this system with the whiteboard here, you can move that around. There's many others. There's presses, just standard hydraulic cylinders, but you get 3 days of really just diving into hands-on experience with the RMCs and physical systems. All right, well, thank you guys for attending, and with that, I'm going to hand it back to AJ.
Thank you so much, David. As mentioned, we have a hydraulic design guide. If you are interested in that, just please visit us at deltamotion.com. On the main page there, you will see a link. It looks just like this, free design guide. We need some information on where to send your copy. If you'll enter that, we'll get you out a free copy of that as soon as we can. So we really appreciate you taking time out of your day to join our webinar today, to listen to the information that we have to share. We sincerely appreciate your interest, and we hope that today's presentation was really valuable information for you. As I mentioned, there's a couple of places to get recordings. They'll be posted at on our website, deltamotion.com. Specifically deltamotion.com/education/webinars. There's also a link from the main page. There are also registration links on that page for webinars that are scheduled in the future. On our discussion forum, which is located at forum.deltamotion.com, there is a webinar topic, and there are links to recordings there. There's also registration links for upcoming sessions there as well. And then finally, on YouTube, we have a Delta channel. It's Delta Motion Control, as you see it there on your screen, all one word. If you search for Delta Motion Control, there you'll find playlists with recordings of all of our webinar sessions. You'll find all sorts of various information or various videos there as well. Thanks a lot and have a great day.